your NCERT textbook is at least 15 years old, maybe as old as you are, your age. That's why a mobile phone in the NCERT textbook is like this. Nowadays you don't see mobile phone with this kind of antenna. My first mobile phone was like this. What is given? A mobile phone lies along the principal axis of a concave mirror. There is a concave mirror, the mobile phone is kept like that. Show by suitable diagram the formation of its image. Explain why the magnification is not uniform. Will the distortion of image depend on the location of the phone with respect to the mirror? Some part is missing, refer NCERT. So it's not clear. I think from the diagram they have given a point here and there is C marked. Maybe they mean to say that it is a center of curvature. Let us say, no problem in that, say this is center of curvature. Assume that this is center of curvature, so the focal point must be here. How to draw the image? Now let us understand it like this. Consider a concave mirror. This is F, this is C. If you have an object kept at C like this, image will also be at C itself, same size but inverted. If you have an object here between C and F, the image will be formed beyond C and that is inverted but larger. If you have an object beyond C here, then the image will be between C and F but will be smaller in size. Once more, concave mirror, principal axis, pole, principal focus, center of curvature. Center of curvature is also equal to 2 times the focal length. Let us place objects here, one object here, same size object here, same size object here. 3 objects at 3 different positions. Let us get their images. Their images can be marked. For the first object between C and F, the image will be outside C, inverted but larger. For object at C, image will be exactly at C, same size. For object beyond C, image will be between C and F but that will be smaller in size. Okay. Now see this. This is your mirror. This is F, this is C. What will happen if you have an object kept like this? If you have an object kept like this, this side is like a vertical object kept at C, its image will be here. This point is C, so its image will be of the same size. So mirror, principal axis, this is a box. It's a box. One edge is at C, another is beyond C. Okay, another is beyond C. So the vertical side at C will have an image at C itself. But this is beyond C. So when the object is beyond C, its image will be between C and F. And the size must be smaller. So this side will have its image somewhere here but smaller in size. And different points will have different images here and the image will appear like this. So if an object is having one edge at C and it is beyond C, image will be between C and F but in this shape. I hope this is clear. Now let us say there is another object in a different way. This is focal point, this is center of curvature. What will happen if you have an object like this? See, one side is at C, one side is at the center of curvature, and we know that the vertical side at center of curvature will have its image of the same size at the same location. But this part is between C and F. It is between C and F. So this vertical side will have its image beyond C, but that will be larger in size. And for any point in between, images will lie along this line. So an object kept like this one will have a distorted image. This is perfect rectangle, but this is a trapezium-like thing. So there is distortion, and the distortion will depend on the location of the object. Fine. Now one more is here, center of curvature. Let us have one object kept like this, partly outside C, partly between C and F. Now you can see that here this portion will have its image of the same size. See, I mean to say, this upper point here will have its image here. This part is within C and F will have its image outside but larger. This part which is outside C will have its image inside here, and the object will look like this. Only this part will have its image like that. So this will be like flipped. If I call this as 1 and 2, one side and two side, this is the image of 2, this is the image of 1. So distortion. I hope this is clear. So if you know this idea, you can work out the question of mobile phone. Depending on the location, you can make a diagram. So this is the, this was the question. It's not exactly clear. Maybe this is at the center. Like I discussed the last point, partly outside C, partly within C. That is okay. If that part was clear, then this should have been. This is a diagram solution given in NCERT, but here what they have taken is that they have taken one edge at C. So its image is here. Whatever coming within C and F will have its image on the other side. And you can see that the part closer to the principal axis will have part closer to the principal axis. So this is how the image is formed. Little bit of drawing, then that will be okay. This is a question from your NCERT exemplar, but this basically tests your basic knowledge. The direction of ray of light incident on a concave mirror is shown by PQ. What is PQ? PQ is this one. This is PQ. Red color may not be visible with the black background, so I am using blue color. This is PQ. Which is the most color, which is the most sensitive color to your eye? Which color is most sensitive? That is yellow. Okay. So this is the incident light, and we know that this incident light is going through the focus, principal focus, and we know any light ray falling on a concave mirror which is going through principal focus will go parallel to the principal axis like this. So 2 is the answer. Out of 1, 2, 3, which is the correct reflected ray? That must be 2. But don't worry, the mirror must be extended a bit here for reflection to take place. Okay, that is only a technical error. So that is the answer. We studied this. A light ray going parallel to the principal axis will go through the focus, and if you reverse it, then it goes through focus, it will go parallel to the principal axis. Another one very similar to the one I did in the class. This is again from NCERT textbook. What is given? An object is placed at 5 cm in front of a concave mirror. Always identify what mirror it is, concave or convex. It is a concave mirror. Object is placed at 5 centimeters. So this must be the object distance u. Radius of curvature is given. R is given here. Find the position, nature and magnification of the image. Concave mirror. Okay. Let us draw concave mirror here. This is principal axis. Somebody asked, is it necessary to draw diagrams? See, initially you draw diagrams and do questions. Later on, without diagram, you will be able to do this. Drawing diagram always helps. Okay. Now, radius of curvature, that means center of curvature is at 15 centimeter. So your focal length must be at 7.5 centimeter. Object is placed at 5 centimeter. That means object is kept here at 5 centimeter. So this is object within focal length. What will happen? Our light ray will go parallel to the principal axis and that will go through the focus. Another light ray will go and hit the pole, it will make an equal angle and it will go like this. They will not converge and meet. So there is no meeting point, there is no real image. But if you look from this side like this, these two light rays will enter your eye and your brain will sense that these are coming from a point somewhere behind the mirror. So you will extend this backward, you will extend this backward. This is where you get the virtual image behind the mirror. You need to find the position, nature and the magnification. You can use mirror equation. But Cartesian sign convention is important. Okay. Now let us do that. So as far as your diagram is considered, object is here, this is a concave mirror. Okay. What is object distance u? Object is kept here. Light goes in this direction, that is taken positive. Object distance must be measured from pole to the left side. So that is negative. U equal to minus 5 centimeters. Focal length is equal to radius of curvature by 2. And radius of curvature is the distance to the center from the pole to the left side, that is minus 15 divided by 2. Image distance we don't know, so no need to give plus or minus sign, leave it as it is. Write the equation. 1 by f is equal to 1 by v plus 1 by u. This gives you 1 by v equal to 1 by f minus 1 by u. This will also give you u minus f divided by uf as 1 by v. It will be useful and easy if you study this equation. What is that equation? The image distance, because in most of the cases they will ask you image distance. Image distance can be calculated using a shortcut equation, uf by u minus f. Use Cartesian sign convention with the sign convention. So I can apply that here. V is equal to u is minus 5 into f is 15 by 2. I can write like minus 7.5. See, 15 by 2 is 7.5 divided by u, again minus 5. Minus sign comes from this equation, but f is already minus, right? So minus 7.5. Okay, so this will give you minus 5 into minus 7.5 divided by, what is this thing? This will give you minus 5, minus and minus will become plus 7.5. So this is equal to minus 5 into minus 7.5 divided by minus 5 plus 7.5 gives you 2.5. Minus into minus plus 2.5 goes in 5 2 times. So this is 2 into 7.5, which is 15 centimeter. This comes with a positive sign. Positive means it must be from the pole, measurement must be from the pole, but in which direction? In the direction of the light. So the image must be somewhere here. So our prediction was correct. Image was here, behind the mirror. Now you want, you got the position. The nature and magnification. Calculate magnification. What is magnification? Magnification is equal to, magnification is given by minus V by U, which is equal to, minus is part of the equation. What happens is that sometimes students will think, okay, negative sign is already there, then why should I apply sign? Minus sign is part of the equation. What is the value of V? V is 15, plus 15 divided by, what is the value of U? U is minus 5. This gives you plus 3. Plus means erect. Plus means erect. 3 means magnify. Okay, so we solved it. Find position. Answer 15 centimeter behind the mirror. Nature erect and virtual because it's behind. Magnification plus 3. This is a very useful question, especially when you drive vehicles, because in a vehicle you have mirrors on the left and the right to see what is happening behind. We call it the rear view mirror, and such rear view mirrors are convex in nature. These rear view mirrors are convex. You know this. In a convex mirror, suppose you are in a road and you want to take a right turn, or maybe you want to cross the road and there are vehicles coming behind. What will you do? You watch the rear view mirror, then you make a decision of when to take, how to take the turn. But there is a big danger hiding in here. What is that? If a vehicle is far behind you and very fast, when you look into the mirror, it will appear to be coming slowly. So you will judge, okay, it's coming slowly, I can take my turn, and you take a turn, then there can be an accident because the speed of the vehicle that you see in the mirror will be actually much lesser than its actual speed. But when the vehicle approaches you, the speed also increases. And there is a particular point at which the speed of the vehicle and the speed of image are equal. But if it is too behind, there is danger. That you can identify here. That's why NCERT purposely put this question. This is life science, something that you learn from your day-to-day life. Suppose while sitting in a parked car, you are in a parked car, a jogger approaching you towards you in the side view mirror. So you are sitting in the car, you watch the side view mirror and you see a jogger approaching you. And the jogger approaching you and you are watching, the mirror has got a radius of curvature of 2 meters. It's a convex mirror, radius of curvature is given as 2 meters, immediately focal length is 1 meter. The jogger is running at a speed of 5 meters per second. Jogger has got a constant speed of 5 meters per second. How fast the image of the jogger in the mirror appear to move when the jogger is 39 meters behind, or 29 meters behind, or 19 meters behind, or 9 meters behind. So they have given 4 values. I think I will solve only with one value, other you can try. How to do this? First of all, your mirror is convex. So this is the mirror. You are looking into the mirror and the jogger is behind. Jogger is object. From the jogger's body, light will fall onto the mirror. So jogger is somewhere here and this is the direction in which light comes. It is positive. Cartesian sign convention. And what is the distance of the jogger? That was 39 meters. And he is moving with a speed of 5 meters per second. See, if it were a plane mirror, we did this previously. If it is a plane mirror, the speed of the image will also be equal to 5 meters per second, only the direction reverses, but here it is not the same. While discussing that question, I told you that you can use the same equation in this case, and I told you V image is equal to minus V square by U square V object. You could have used it here, but we don't know what is V. So we have to find V. More than that, this is an average speed of 5 meters per second. Okay. So let us do that using your mirror equation. Radius of curvature, center of curvature will be here. So radius of curvature R is equal to, it is given 2 meters. But you can see that is in the positive direction, so that is plus 2. You already know focal length of a convex mirror is positive. So let us write, let us say, what is U? What is U here? U is equal to minus 39. I hope it's clear. U equal to minus 39 meter. Why is it minus? All here measurement opposite to the incident light. Okay. What is F equal to? F is equal to plus 1 meter. R equal to 2, F is equal to 1. What do you want? You want to find V. What is the equation for V? V equal to UF divided by U minus F. So, U is minus 39 into F is 1 divided by minus 39 minus 1 equals minus 39 divided by minus 39 minus 40. So, this gives you 39 by 40 meter. 39 by 40 is little less than 1, and that is positive. That means when the jogger is at 39 meter, image is somewhere. See, this is 2 meter, focal length is 1 meter, this is little less than 1 meter. So, the image will appear here, smaller in size. So, when he is at 39, image is here. We got image. Okay. Now what? Jogger is not at rest. He will move forward. In 1 second, he can move 5 meters forward. So, after 1 second, the jogger will move to a new position. And this distance moved is equal to 5 meters because it's his speed. So, what is the new distance between the jogger and the mirror? Earlier, this much was 39, now 5 less. So, this becomes 34 meters. Same way, you have to calculate the new image. So, this was V in the first case. So, for that, now what to do, where to do, where to do, here. So, here I am taking U equal to minus 34, F is equal to plus 1. I use the same equation, V equal to, I am not writing equation, I am directly doing that, minus 34 into 1 divided by minus 34 minus 1. This gives you 34 divided by 35. And 34 by 35 is also less than 1, but it is also less than 39 by 40. You can work out. So, what happens? When the jogger approached your car, you are parked, jogger approached, the image, what will happen to the image? Image will come here. Image also moved. Object moves 5 meters in 1 second, and the image moves this much in the same 1 second. It moves this much in 1 second. How much? How much? First distance from the pole. See, first image was 39 by 40 from the pole. First image from here to here, 39 by 40. Second image from here to here, 34 by 35. So what is the distance moved by the image? Okay, distance moved by the image is nothing but 39 by 40 minus 34 by 35 in 1 second. So you work out this one, I think this will roughly come around 1 by 280. You work out 1 by 280, and this is the distance moved in 1 second. So this much meter in 1 second is the average speed of the jogger at that point. Okay. Now what did we do? We assumed 39 meter initial. We calculated the image distance. We got 39 by 40 behind the mirror. Then we assumed that the jogger moved 1 second, for 1 second 5 meter. In that 1 second you got a new image position 34 by 35. We know the speed of the jogger is 5 meter per second throughout that 1 second, and here we calculate the average speed. How to calculate average speed? We calculate the distance moved by the image, and that distance is 1 by 280 meter per second approximately, and this is moved in 1 second. So average velocity is nothing but displacement by time. So that is 1 by 280 meter by second. This is an average velocity calculation. You can also use the earlier equation of V image equal to minus V square by U square V of the object. This can also be done. Okay. Now if you work out like this, you can work out for 29 meter, then 19, and all these values you can work out. Okay. I have done this here. For U equal to 39 meter, your answer is 1 by 280, the previous one what I did. But when it is 29 meter, the jogger approach it, it is 1 by 150. You can see the speed has increased. Then at 19 meter, 1 by 60, at minus 9 meter, 1 by 10. You can take this to say minus 2 meter and work out. You will get a much lesser value. So what does it mean? It means that when the object is far behind, speed is very less. I told you before, if the vehicle is far behind, the speed will be much lesser. Compare, actual speed was 5 meter per second, but your mirror image is giving 1 by 280 meter per second. Then we become 1 by 150, 1 by 60, 1 by 10, and it is increasing, and when it comes at the center of curvature, it will become exactly the same. V and U will be equal. So that is why I told you, when you watch objects in rear view mirror, there is a danger, hidden danger, that far away objects appear slower than they actually are. Only when they approach, their speed appears to be increasing. This is written in a different way in the rear view mirrors. They say the objects appear as the different distance as they actually are. I hope it's clear, useful for both exam and your life. Next we will do a question about convex mirror. Okay. There is a 4.5 centimeter needle. What is the meaning of needle here? Needle stands for object. That's actually a common usage, needle, because you know in case of mirrors we draw object like this. This is sometimes referred to as needle. Okay, so don't worry. A needle is placed at 12 centimeter away from a convex mirror, and focal length of the mirror is 15 centimeter. Give the location of the image and the magnification. Okay, so here you have convex mirror, principal axis. Okay, focal length of the convex mirror. Focal length is given 4.5 centimeter is the height of the object. 12 centimeter is the object distance. What you need to find out is the image distance and the magnification. So both magnification and image distances are question marks. Let us see what is focal length. Cartesian sign convention. light should be incident. The object is kept here, okay, at 12 centimeter from the reflecting side. So from the object, light will go in this direction. This is positive direction. Focal length of convex lens is measured from the pole in the direction of light, because the focal point is here, center of curvature is here. So focal length is positive 15 centimeter. It's given. Height of the object is measured perpendicular upward, so that is positive 4.5 centimeter. Object distance is measured from the pole to the object, that's opposite to the direction of light, so that must be minus 12 centimeter. So all the basics are set. Now what? We can find out image distance by using that shortcut equation. What was that? UF by U minus F. Apply with Cartesian sign convention, minus 12 times focal length is plus 15 divided by minus 12 minus 15. This gives you minus 12 into 15 divided by minus 12 plus minus 15 minus 27. Okay. You can divide 12 by 3, 27 by 3. So minus 12 by 3 gives you minus 4, or rather minus and minus cancel, so no need to take that minus sign. This is minus 27, minus minus cancel. So we have 12 by 27. You can divide 12 by 3, you get 4. You can divide 27 by 3, you will get 9. Then into 15. 15 fours are 60, so you get 60 divided by 9 with the positive sign. So this is the image position, and 60 by 9 will be little less than 7, right? So it will be something around 6 point something, and that is a positive value, so that should appear somewhere here. Focal length is 15 centimeter and this almost half, so somewhere here you get the image. Okay, so the image will be available here, this part. Okay. What is magnification? Magnification is given by minus V divided by U, which is equal to minus V is 60 by 9 divided by U is 12, minus 12. So you get a positive magnification, and this is 60 divided by 9 into 12. So this gives you 5 by 9. Magnification come with a plus sign, which means that it's an erect object, erect image. So image will be erect. What about the size? What about the size? Size must be smaller. How to find size of the image? Use the equation h dash by h is equal to magnification. So h dash is equal to magnification into h, and magnification is 5 divided by 9 into height of the object is given as 4.5. So 4.5 goes in 9 2 times. This gives you 5 divided by 2, or the height of the image will be equal to plus 2.5. So you get an image like this, 2.5. Okay. So we are able to do convex mirror. We applied Cartesian sign convention. What was asked? Location and magnification. Height of the image was not asked, but still we are able to do that.